Assalamu alaikum everyone. The topic for today is differentiation. So what is differentiation? We differentiate a function or fx which is also equals to y with respect to x, means the function will have x in it. So let's say that this is x to the power 7. Before that we will see how do we write differential or derivative. When we differentiate something with respect to x, you will see WRT, with respect to x. Now, how do we write the differential or the derivative? We write it as dy by dx and read it as differentiating y with respect to x. Let's start with the general formula. Suppose this is the question, x to the power 7. Now, if we take this 7 as n, x to the power n, we will write the general formula. The general formula is you bring the n down, x to the power n minus 1. The first case that we are doing is that we have a variable with a power, but we do not have any coefficient attached with it. So according to this general formula, if we differentiate x to the power 7, this becomes 7x to the power 6. 7 minus 1 is 6. Second one, when we have a variable in the denominator, we can differentiate when we have a fraction, but to make it easy, we will bring it in the numerator. So according to laws of indices, when x to the power 5 from the denominator comes in the numerator, it becomes x to the power minus 5. We can differentiate it in the same way by using the general formula. We bring the power down, minus 5, x to the power minus 5 minus 1 gives you x to the power minus 6. Now, when we have a radical sign attached with a number and there is some number on the tail, even if there is no number on the tail, we will first have to bring it into fractional indices. So when we remove the radical sign, this becomes x to the power 1 upon 3. Whatever is on the tail comes in the denominator of the power, and 1 comes in the numerator if there is 1 inside. If there is something else inside, for example x to the power 2 and on the tail we have 5, this becomes x to the power 2 upon 5. Whatever is inside comes in the numerator and whatever is on the tail comes in the denominator. Okay, coming back to x to the power 1 upon 3. When you differentiate it, dy by dx of this one becomes, we bring the power down, 1 upon 3, x to the power 1 upon 3 minus 1, which ultimately becomes 1 upon 3 x to the power minus 2 upon 3. If we want to write it as a positive power, we can write 1 upon 3 x to the power 2 upon 3, right? So this is the differential of x to the power third root of x. Whenever we have power 1 attached with x, the differential of this is 1. Why the differential of this is 1? Not because I am saying it, I am going to show that to you. So we bring the power down, dy by dx of x to the power 1 is equals to power 1 x power 1 minus 1, which is equals to 1 into x power 0. Anything to the power 0 is equals to 1. So this is 1 multiplied by 1, which is ultimately equal to 1. What happens if we have a coefficient attached with x and x has the power 1? We will look at it as the lecture proceeds. But before that, I would like to tell you something. Differential of a constant, which means that a number which does not have any variable attached with it, differential of a constant is 0. Why differential of a constant is 0? Not because I am saying it or you just have to remember it. I am going to prove it to you once we start talking about gradient. Okay. So moving forward, suppose we have a question which says, I'm going to erase it. I had already solved it for somebody, for my students basically, not somebody. Alright, so case number 2. When we have a coefficient attached with x and x has some power as well attached to it, what do? We do the same thing, but what do we do with the coefficient? We let the coefficient stay where it is. So the general formula becomes coefficient multiply by power into expression. And what happens to the power of expression? Power minus 1. So in this case, if we try to differentiate this expression, 2 stays where it is, multiplied by minus 3. X to the power minus 3 minus 1 is minus 4. So the answer is minus 6 x to the power minus 4. Let's move ahead. Let's look at this expression. What do we do for this one and how do we differentiate this one? We first open this bracket, expand this bracket. 2 bracket 2x square plus 6x minus x is plus 5x minus 3. Now you bring the 2 inside. 4x square plus 10x minus 6. And now you differentiate it. How do we differentiate it? We differentiate each term separately. dy by dx of 4x square plus dy by dx of 10x minus dy by dx of 6. Differential of 4x square is 8x plus differential of 10x is 10 minus 0. Why 10? 10x is equals to, we let the coefficient stay as it is, power 1 into x power 0. 1 minus 1 is equals to 10 multiplied by 1 or 10. Right? Okay. For this one, so ultimately 8x plus 10. This is the differential. Now let's talk about this one. This is one expression and we have to differentiate it. So this can be differentiated as it is, but first we will bring all the denominator variables in the numerator. This is 3x to the power 4. 1 upon 2 is a coefficient, so 2 stays in the denominator, only x to the power 2 goes up in the numerator. So this becomes x to the power minus 2 upon 2 plus under root x is the power x to the power half. This half goes in the numerator. So this becomes 4x to the power minus half and this is plus 5. I differentiate all of them separately. So this becomes 4 into 3 x to the power 3 minus 1 upon 2 is the coefficient multiplied by power, which is minus 2. X to the power minus 2 minus 1 is minus 3 plus 4 bracket power is minus half, x to the power minus half minus 1 and differential of 5 is 0. So this becomes 12x cube plus x to the power minus 3. This is plus minus 2x to the power minus 3 upon 2, or I can write it as 2x cube plus 1 upon x cube minus 2 upon x to the power 3 upon 2. I will write it like this. Okay, let's move ahead. We saw that whenever we had a coefficient attached with x where x had power, we let the coefficient stay where it is. But what if the expression that we are talking about is a combination of terms and not just a variable? Like this one, 3 minus 4x whole to the power 5. How do we differentiate it? We differentiate it in this way. We write power into expression power minus 1 into differential of the expression inside. Differential can also be written as f dash x, right? dy by dx is f dash x. Whenever we have an entire expression here, we are going to differentiate the expression as well. Whatever is inside the expression, not just the powers, right? So what do? Power 5. 3 minus 4x power 4. What is the differential of the expression 3 minus 4x? Differential of 3 is 0. Differential of minus 4x is minus 4. So the answer is minus 20. 3 minus 4x to the power 4. That's the answer. Okay, now let's look at this one. We have a coefficient which is a fraction, and the coefficient is 1 upon 4. So what do? In this one, we write the coefficient as it is if we have it. So we have 1 upon 4 multiplied by power multiplied by 5x minus 2 to the power 7, and differential of the expression, which is 5. Differential of 5x is 5 and differential of 2 is 0, right? So this and this cancels. This becomes 10 5x minus 2 to the power 7. How 10? This 2 and this 5 multiplies with each other. Now the next one, what do we do with this? We bring this x in the numerator first before we differentiate. X squared minus 5x to the power minus 1 whole to the power 5. The mistake that students do is they try to open this bracket, which we cannot. We actually can, but it cannot be opened like x squared to the power 5 minus 5 upon x to the power 5. No, that's wrong. Powers greater than 4 will be opened using binomial expansion and binomial theorem, which we are not going to discuss right now. So we better differentiate it using this simple rule. So let's differentiate it. This is 5 bracket x squared minus 5x to the power minus 1 whole to the power 4. And now what is the differential of x squared? It's 2x, and differential of minus 5x power minus 1 is minus 5 multiplied by minus 1 and x to the power minus 2. So this becomes 5 into x squared minus 5x to the power minus 1 whole to the power 4 into 2x plus 5x to the power minus 2. You want to write them in positive indices? You can. Okay, next is this one. We have a coefficient attached with it and the entire expression is in the denominator. What do? We do the same thing. We bring the entire expression in the numerator. This becomes 3 bracket 3x plus 1 power minus 5 upon 2. Now what do? We differentiate it the same way. 3 upon 2 power minus 5, 3x plus 1 minus 6, and differential of 3x plus 1 is 3. So this is, nothing can be cancelled. We get minus 45 upon 2, 3x plus 1 power minus 6. This is the differential, total differential of this expression. Next, we have a third root in the denominator. What do with this? We do the same thing. We bring the entire expression in the numerator. First, we change it into fractional indices. So this becomes 6 upon 2 minus 3x to the power 1 upon 3. this comes in the numerator, becomes 6 into 2x minus 2 minus 3x power minus 1 upon 3. Now we differentiate it. This is 6 into power minus 1 upon 3 into 2 minus 3x power minus 1 upon 3 minus 1, and differential of 2 minus 3x is minus 3, right? This minus 3, this 3 cancels, minus minus becomes plus. So we have 6 bracket 2 minus 3x to the power minus 4 upon 3, or we can write 6 upon 2 minus 3x to the power 4 upon 3, right? Okay, let's move on to this one. We can see that we have an entire expression in the denominator, but there is no power attached with it. The mistake that students do here, an error that they make, is they write 8 upon x squared plus 8 upon 2x, and then they think that they will simplify it and then they will differentiate it. This is wrong. If you have a plus sign in the denominator, you cannot break it and you cannot assign the denominator separately to the numerator. So avoid the mistake of breaking the denominator. What do we do instead? We place it in the bracket and take the entire expression in the numerator. Becomes 8 bracket x squared plus 2x to the power minus 1. Now we differentiate it. 8 bracket minus 1 into x squared plus 2x to the power minus 2. Minus 1 is minus 2. Differential of the expression is 2x plus 2. Right? Now, what do we do? Minus 8 into x squared plus 2x to the power minus 2 into 2x plus 2, or I take out common, 2 common from here, bring it outside, multiply with 8, becomes minus 16 x squared plus 2x to the power minus 2 into x plus 1. This will be your final answer. You can leave it over here also. You don't need to worry about it, and that will also be considered as the correct answer. Let's move forward. I did say that I will explain to you later on why slope of a constant is equals to 0. So it's time that I tell you that. Differentiation is carried out to find out the slope of a curve. In coordinate geometry, we have learned that we can easily find out slope of a straight line if we know 2 points, like rise upon run, or y2 minus y1 upon x2 minus x1 is the formula for slope, but the slope of the curve keeps changing at every point. We already know that. So in ALevels, what we used to do was that we used to draw a tangent to the curve at a point where we want to find out the slope, and the slope of the tangent and the curve at that point would be the same. So we used to draw the tangent, but now in ALevels, what we are going to do is we are going to differentiate the equation of the curve to find out slope of the curve at a certain point. And whenever we will have, obviously we'll have x inside the slope, we'll put the value of the x coordinate of the point at which we want to find out the slope, and we will find out the slope. Second thing that I want you to know is that these turning points from where the graph turns are called stationary points, and at stationary point the slope is always equal to 0. Now that I've told you that slope of the curve is the differential, means dy by dx, now let's have a look at a graph. Suppose this is a graph, this is a grid right now, not a graph, this is a grid, and I draw a line parallel to the x-axis and cutting the y-axis. So let's say this is the line. This is y is equals to 3. Fx is equals to 3, or y is equals to 3. Here I had written 110 or any constant. So y is equals to 110. or any constant. So we know that when a line is parallel to the x-axis and it cuts the y-axis, it passes through the y-axis, the slope of this line is 0. That is why dy by dx of a line of a constant is 0. Y is equals to 3, y is equals to 110, dy by dx will be 0 because dy by dx is the slope of that line. Okay, so let's move ahead with the question involving slopes. Find the gradient of the tangent to the curve y is equals to this at the point 1, 4. The question here is, why aren't we using m is equals to y2 minus y1 upon x2 minus x1 when we are finding the tangent, when we are finding gradient of the tangent, which is a straight line? Here we don't want to find the gradient of the curve. Why are we not using this formula that is relevant? We're not using this formula because we don't have 2 points over here, right? So if we don't have 2 points, we can't say that the question is missing any detail. We will move to another method of finding out the gradient, which is finding the differential or the derivative of the equation. So let's find out differential of the equation. Equation is x bracket 2x minus 1 into x plus 3. First I expand the equation. This becomes x into 2x square plus 6x minus x is plus 5x minus 3. Now I bring the x inside, 2x cube plus 5x square minus 3x. Now I differentiate every term separately. This becomes dy by dx is equals to 6x square plus 10x minus 3. This is the differential. Now we have to find out the slope. This differential is the slope or the gradient. To find out the value of gradient, the numerical value of gradient, I will pick the x coordinate from this point and plug it into the gradient that I have found out. So x is equals to 1. dy by dx is equals to 6 into 1 square plus 10 into 1 minus 3. 6 plus 10 minus 3 is equals to 13. Gradient or dy by dx is 13. So this is the gradient of the tangent, or this is the gradient of the curve. This is the gradient of the curve at that point from where a tangent passes through that curve. Tangent is a line that touches the curve at only one point. So at the same point, if the tangent passes through this point, the curve of the gradient, gradient of the curve and that of the tangent will be the same. Moving on to the next question. This question says the curve, this has a gradient 3 when x is equals to 1 and has a gradient minus 51 when x is equals to minus 2. So we have two conditions. We have been provided with the two x values and two values of gradient. We have to calculate a and b. So why do we have two conditions? We have two conditions because there are two missing variables that we have to calculate. In mathematics, always remember that the number of equations required to find out the missing variable should be equal to the number of variables. Like for example, here we have two missing variables, two variables that we have to calculate. So we will need two equations. If we don't have two equations, means the question is incomplete, which doesn't really happen. But I'm just giving you the logic. Why do we need two equations and two conditions? Let's start. First, let's find out dy by dx, which is the gradient. So dy by dx is equals to 4ax cube. Why am I not doing anything with x? Because x is with a, because a is a constant. I'm not going to do anything with b as well because b is also a constant. So we have plus 2bx plus 1. This is dy by dx, or this is the gradient. So gradient is 3 when x is equals to 1. In place of gradient, I plug in 3, and in place of x, I put 1. 1 cube plus 2b plus 1. I bring that 1 on the other side, becomes 2 is equals to 4a plus 2b. I divide the entire equation by 2, and the final equation is 1 is equals to 2a plus b. This is equation 1. For the second condition, gradient is equals to minus 51 and x is equals to minus 2. So I put minus 2 in the gradient. 4a minus 2 cube plus 2b minus 2 plus 1. 1 goes on the other side, becomes minus 52. 4 into minus 8 is minus 32a minus 4b. I divide the entire equation by 4. I get minus 1/3 is equals to minus 8a minus b. This is equation 2. I have deliberately not divided the entire equation by minus 4 because I want to add both the equations. Why am I adding both the equations? To eliminate b. So I write 1 is equals to 2a plus b. I add both the equations. Minus b plus b cancels. This becomes minus 6a. This becomes minus 12. A is equals to 3. Our work does not finish here because we have to calculate b also. I put b in a is equals to 3 in equation 1. 1 is equals to 2 into 3 plus b. I take this on the other side. So this is see. Sorry, I made a mistake. A is equals to 2, not 3. I'm so sorry. I put a is equals to 2 in this equation. This is 1 is equals to 2 into 2 plus b. 1 minus 4 is equals to b, and b is equals to minus 3. Okay? All right. Now let's move ahead. This is the question. It says that find the coordinates of the stationary point. We learned earlier that the gradient at stationary point is equals to 0. So first let's find out the gradient. How do we find out the gradient? By differentiating this expression. So the gradient is dy by dx is equals to half x square minus 10x plus 26. Half minus 1 is minus half. Now we differentiate the expression inside. 2x minus 10. This is dy by dx. Now what do? I take out 2 common from this one. So this becomes 2 upon 2 into x square. I will take this entire expression in the denominator for a reason, right? So what am I going to do? 2 bracket 2 bracket x minus 5 upon x square minus 10x plus 26 to the power half is equals to dy by dx. This dy by dx is at the stationary point. So in place of dy by dx, we will write 0. This 2 cancels. So we have x minus 5 upon x square minus 10x plus 26. You can write it in under root also. That is also correct. It's going to become 0 anyways. We'll see in a while why. So we write 0 over here. Okay. So we cross multiply. This becomes x minus 5 is equals to 0. X is equals to 5. Our work does not end here because it says coordinates of the stationary point. We know that coordinates mean we need the x coordinate and the y coordinate also. So what's the corresponding y coordinate? What do? We put this x is equals to 5 in the original equation to find out y, right? So let's plug it in. 5 square minus 10 into 5 plus 26 to the power half is equals to y. We have 25 minus 50 plus 26 to the power half is equals to y. 25 plus 26 is 51 minus 50 is 1 to the power half, or under root 1 is equals to y. So y is equals to 1. The coordinates that we are looking for are 5 and 1. 1 to the power anything is equals to 1. So we stop right here, and in the next lecture I'm going to start off with gradient of normals and tangents and equations of gradients and normals using differentiation. Till then, I'll see you. Take care. Allah Hafiz.